Welcome to the first lesson in Chapter 8 of the Pearson Geometry video series. In this lesson, we will review what you learned in Algebra 1 about the patterns of special right triangles. The first special triangle is the 45-45-90 triangle. Looking at the picture, we can see the two acute angles are congruent, so we know by the converse of the isosceles triangle theorem that the corresponding sides, or the legs, are also congruent. So that means that if this is x, then this is also x. Alright, so to try and find a pattern, we are going to go ahead and use the Pythagorean theorem to find a general rule and find x given the hypotenuse. So Pythag says a squared plus b squared, so we're going to say x squared plus x squared equals 1 squared. Simplifying that, we're going to get 2x squared equals 1. Divide both sides by 2, and we get x squared equals 1/2. Take the square root of both sides, and we get x equals the square root of 1/2, which equals the square root of 1 over the square root of 2, which equals 1 over radical 2. Now, we're not allowed to have radical 2 in the denominator. We talked about that in the last lesson. So we're going to multiply both sides, top and bottom, by radical 2, which is another way of saying 1. And we're going to end up with radical 2 over 2. So, when the hypotenuse is 1, we can take 1/2 of that, because this is the same as 1/2 times radical 2. So we're going to take half of that and multiply it by radical 2. Okay, now let's take a look at when we are given one of the legs. Okay, so we know that given one of the legs, the other leg is also going to be the same thing. So we can go ahead and use Pythag again in order to figure out how we would find the hypotenuse given one of the legs. So we're going to say 1 squared plus 1 squared is equal to x squared, which is like a squared plus b squared equals c squared. So 1 squared and 1 squared is 1 and 1, so we get 2 is equal to x squared. So now we are going to take the square root of both sides, and x is going to be equal to the square root of 2. So when the legs are equal to 1, we are going to multiply them times radical 2. This is the same as 1 radical 2, so this would equal 1 times radical 2, which we could just say is radical 2. All right, let's look at some examples. So, if we bring out the cards, we know that if we are given one leg, the other leg is going to be the same. And in order to figure out the hypotenuse, we're just going to multiply it by radical 2. So this becomes x radical 2. All right, so that makes sense that if we're given the hypotenuse in terms of radical 2, if the leg times radical 2 is the hypotenuse, then to find the leg, we're simply going to divide by radical 2. So if I divide this by radical 2, I end up with y, and of course these are going to be the same. Now, it's not quite as easy if your hypotenuse is given to you and it's not in terms of radical 2. So we would want to still divide that by radical 2. All right, so z divided by radical 2 would look like that, but we're not allowed to have that there. So we're going to multiply top and bottom, numerator and denominator, by radical 2, and we get z radical 2 over 2. Okay, so this is the same as 1/2 times radical 2. So what we're really doing is we are multiplying this by 1/2 and radical 2. So we're dividing by 2, so we're going to get 1/2 z times radical 2. Okay, which is the same as z radical 2 over 2. It makes a little more sense when you're looking at numbers. So let's look at some examples. Okay, so right here we are given one leg with a length of 8. So we know that this other leg will also be 8. And then x, the hypotenuse, is going to be equal to 8 times radical 2, or 8 radical 2. In the second example, we're given a leg that's 14, so we know that x is equal to 14 also. And then the hypotenuse is the leg times radical 2, so we're looking at 14 radical 2. Okay, over here in example 3, we're given a leg of 18, so we know the other one is also 18. And then 18 times radical 2 is going to be our hypotenuse. And then lastly, in example 4, we have a hypotenuse without a radical 2. So we're going to take half, which is going to be 9, and multiply it times radical 2. All right, let's take a look at another special triangle, which is our 30, 60, 90. Okay, so with the 30, 60, 90, we're going to start with an equilateral triangle. Okay, an equilateral triangle has 3 angles that are 60 degrees, and all 3 sides are the same. And then we're going to buzz it bzzz, right down the middle, and we're going to push 1/2 of it over here. Okay, so this hasn't changed. This right here, where we buzzed it in half, is perpendicular, so we have a right triangle. So if this angle right here was cut in half, our 60 became 30, and voila, we have a 60, 30, 90 triangle, or 30, 60, 90 triangle if you want to say it in order. All right, so now let's figure out what the relationship is to the sides. So the hypotenuse is the original side length, and at an equilateral triangle all the sides are the same, so if this is 1, then this would be 1. Okay, now this side down here was the original side, which was 1, and it was cut in half. So this is going to be 1/2. So if you're given the hypotenuse, you cut it in half to get the shorter leg. Now to get the longer leg, we're going to use the Pythagorean theorem. So we are going to call this x for right now, and we're going to square both legs, add them up, and set them equal to the hypotenuse squared. So a squared plus b squared equals c squared. Or x squared plus 1/2 squared equals 1 squared. Okay, so we've got x squared plus, and then 1/2 times 1/2 looks like this. 1/2 times 1/2, multiply across, and we get 1/4. So we've got x squared plus 1/4 equals 1. Now we're going to subtract 1/4 from both sides, and x squared equals 3/4. And we're going to take the square root of both sides. So x is equal to the square root of 3/4, which is the same as radical 3 over radical 4, or radical 3 over 2. Okay, now, if we do a little fancy maneuvering here, this is the same as 1/2 times radical 3. Where did we have 1/2? We had 1/2 right here. So this x is the same as 1/2 radical 3, which we go ahead and write like this, radical 3 over 2, because we simplify this. But let's look at the relationship. So we started out with 1. To get the shorter side, we cut it in half, and then we take the shorter side and we multiply it times radical 3. Let's go back to the cards. So we have some 30, 60, 90 triangles here. If we have x, then we take half of that, so we have 1/2 x, or x over 2. And then if we want the longer side, we're going to multiply the shorter side by radical 3, so it would be x radical 3 over 2. Now if we are given the shorter side, then we can double it to get the longer side, which would give us 2y, and then we would multiply the shorter side by radical 3. So we get y radical 3. And then finally, if we're given the longer leg, then we're going to divide that by radical 3. Okay, so in order to get the shorter leg. So we would divide that by radical 3, and then, actually that would be right here, and then we would double this in order to get this one. So it's going to be 2z over radical 3, and then of course we would get rid of that radical in the bottom. That's how it works. Okay, let's look at some examples. So in the first one, we have the shorter leg, which is 8, so we can double it to get the hypotenuse, which is going to be 16, and we're going to multiply the shorter leg by radical 3 in order to get the longer leg. In example 2, we're given the shorter leg, so we're going to multiply it by 2, which gives us 1, and we're going to multiply it by radical 3, which gives us radical 3 over 2 to get the longer leg. In example 3, the shorter leg is 14, so we can double it to get the hypotenuse, and we'll multiply it by radical 3 in order to get the longer leg. And finally, here we have 12 as the shorter leg, so we double it, and the hypotenuse is 24, and we multiply the shorter leg by radical 3 to get the longer leg, which brings us to our theorems. So, in our theorems, we know that in a 45, 45, 90 triangle, the legs are congruent and the hypotenuse is radical 2 times the leg. All right, so looking at this, we want to figure out what the sides are on this square. So we have a 45, 45, 90 triangle. We know what the hypotenuse is, and if you remember from what we did before, we're going to take half and multiply it by radical 2. So if we take 1/2 of 200, we get 100, and then we multiply it by radical 2, and we get 100 radical 2. So the side lengths are equal to 100 radical 2. All right, now let's take a look at the 30, 60, 90 theorem. Okay, in a 30, 60, 90 theorem, the shorter leg is half the hypotenuse. The shorter leg is half the hypotenuse, and the longer leg is radical 3 times the shorter leg. Okay, the shorter leg is half the hypotenuse, and the longer leg is radical 3 times the shorter leg. So let's take a look at this. In this problem with Alejandro, he's making horizontal and vertical supports given this side length BC of 10 feet. So he wants to know if a 12-foot long board is going to be enough for both of these supports. So we're going to add those together, but let's figure out what they are first. So the shorter leg in a 30, 60, 90 is half the hypotenuse, which means 5 feet. Okay, and the longer leg is radical 3 times the shorter leg. So 5 radical 3 feet. Okay, that doesn't quite help us. We know it's going to be 5 feet plus 5 radical 3 feet, but it would be helpful to know exactly how much 5 radical 3 is. So if we go ahead and multiply this, radical 3, and then times 5, we're going to get 5 feet plus, and our decimal equivalent is going to be about 8.7. It's like 8.66 something something, but we'll round it to 8.7 feet. And if we add those together, we're going to get 13.7 feet. So is our 12-foot board going to be long enough? No. All right, now this is a flash from the past, and we're looking at whether or not these are right triangles. Okay, so you're going to multiply or square the legs and set them equal to the hypotenuse squared. In other words, we want a squared plus b squared to equal c squared. If it doesn't, then it's not a right triangle. So you're going to take the two smaller legs each time. So we're looking at 35 squared plus 37 squared should be equal to 71 squared if it's a right triangle. So 35 squared plus 37 squared is 2594. And 71 squared is equal to 5041. So if you open your hands like a right triangle, and then you stretch them outward because your hypotenuse is longer than a right triangle, then you'll see that you have an obtuse triangle. So this one is not a right triangle. This one is obtuse. All right, let's try that again with this one. So we've got 40, 41, and 11. So we want 11 squared plus 40 squared to equal 41 squared. Okay, and 11 squared plus 40 squared is 1721. And 41 squared is 1681. Okay, not a right triangle because they're not equal. And this time, when you move your hands, so you start out with a right triangle, and then the hypotenuse is too short. So you can tell this one is going to be acute. All right, finally we have 20, 21, and 29. So we're going to say 20 squared plus 21 squared should equal 29 squared. So 20 squared plus 21 squared is 841. And 29 squared is also 841. So yes, we have a right triangle. All right, the last problem also involves the Pythagorean theorem. And we want to know which of these diagonals is longer. Okay, so we've got a couple different things here. First of all, this goes from the front corner to the lower back corner. So this is crossing the plane right here. So we have one leg that's 15 feet, and then we have one leg that's the hypotenuse of this 3 by 4 triangle, right triangle. So if we figure 3 squared plus 4 squared and take the square root, we're looking at 9 plus 16, so the square root of 25. So this right in here is 5 units. So we're looking at now this side squared plus this side squared in order to figure out the hypotenuse. So we're looking at 5 squared plus 15 squared, which is going to be 25 plus 225, which is about 250. Okay, and then the square root of 250 is going to be in the neighborhood of 15.8. Okay, now we're going to do the same thing for this one. Front corner to back corner, so it's crossing the plane right here. So we want this side squared plus this side squared. So we've got 4 squared plus 12 squared, and that's going to be 160 plus 81, which is about 241. And when we take the square root of that, we're going to get somewhere in the neighborhood of 15.5. So it looks like prism P has the longer diagonal. And that is pretty much it. See you next time.